NASA has just released the clearest image of a bizarre structure on Mars, leaving scientists and the world astounded. Could this be the remnants of an ancient civilization? Or is it a naturally occurring phenomenon beyond our comprehension? What if Mars holds secrets of life, past or present, hidden beneath its surface? With underground oceans, mysterious seismic signals, and evidence of once flowing rivers, the red planet continues to defy expectations. Are we on the brink of discovering proof of extraterrestrial life? Join us as we uncover the shocking truths behind this image and Mars's greatest mysteries. Part 1. The mysterious image and strange structure. NASA's release of the clearest image of a mysterious structure on Mars has ignited a storm of intrigue. This geometric anomaly, resembling a perfectly formed pyramid, stands isolated in the planet's dusty terrain. Its sharp edges, symmetrical shape, and unusual prominence make it unlike anything previously captured, while some experts suggest it may be the result of erosion or geological activity. Others argue it bears the hallmarks of intentional design. The question remains, could this be the work of an ancient Martian civilization? Or is it a natural formation that simply mimics artificial precision? Comparing this image to previous photos from Mars reveals a stark contrast. Earlier images showed scattered boulders, craters, and barren landscapes, but nothing as geometrically striking as this structure. The details captured by the Perseverance rover's advanced imaging tools hint at something unprecedented. Even skeptics admit that this discovery challenges our understanding of Martian geology and raises questions about the planet's history. The mystery deepens when we draw parallels with enigmatic structures on Earth. The Great Pyramid of Giza in Egypt, for instance, has fascinated humanity for centuries. Its precise construction and alignment with celestial bodies continue to spark debates about the engineering prowess of ancient civilizations. Similarly, the Nazca lines in Peru, vast geoglyphs visible only from the air, leave us wondering about their purpose and the people who created them. Could the Martian structure be the extraterrestrial equivalent of such earthly marvels? If this anomaly were artificial, the implications would be staggering. It would suggest that intelligent life once thrived on Mars, capable of constructing monuments that defy time. But what happened to them? Did they fall victim to the same catastrophic changes that turned Mars from a lush, warm planet into the arid desert we see today? Or did they abandon Mars, leaving behind these enigmatic remnants as a testament to their existence? Some researchers propose that this structure might not just be a relic but a message. If ancient Martians sought to leave a sign for future explorers, what would they want us to know? Could this be a beacon of hope, a warning, or simply a record of their presence? Such questions push the boundaries of both science and imagination. While many theories lean toward the extraordinary, natural explanations cannot be dismissed. Mars's intense weather systems, volcanic activity, and wind erosion have shaped its surface for billions of years. It's possible that the pyramid-like structure is the result of geological processes that created a perfectly symmetrical formation by chance. But even this raises another question. How likely is it for nature to create something so precise and isolated? Adding to the intrigue is the context of Mars's geological history. The planet's ancient environment, marked by flowing rivers, vast lakes, and a thicker atmosphere, suggests that it was once capable of supporting life. If intelligent beings existed during that period, they would have had the resources to build such monuments. This discovery ties into broader questions about Martian habitability and whether life, intelligent or microbial, once thrived there. The parallels between this Martian structure and Earth's ancient wonders spark a sense of connection. On Earth, structures like the pyramids or the Stonehenge served as markers of cultural, spiritual, or scientific significance. If the Martian anomaly serves a similar purpose, deciphering its meaning could unlock secrets not just about Mars but about humanity's place in the cosmos. Critics caution against jumping to conclusions, emphasizing the need for rigorous analysis. Yet, the very existence of this structure compels us to probe further. What tools or techniques could have created it? Could it be linked to other Martian anomalies, such as the controversial face on Mars, or unexplained seismic patterns detected by the InSight lander? This image is not just a snapshot, it's a gateway to profound questions. Is it a natural formation, a relic of an ancient civilization, or a sign that Mars was once a vibrant world with its own stories? As we analyze this discovery, one thing is certain: Mars continues to surprise us, challenging what we thought we knew and inviting us to imagine the unimaginable. With each discovery, Mars reminds us of humanity's enduring quest for understanding, whether this structure is the result of natural forces or ancient architects. Its mere existence deepens the enigma of the red planet, compelling us to continue exploring its mysteries. Part 2. The underground ocean and the mystery of water on Mars. Among Mars's most groundbreaking discoveries is the detection of a vast underground reservoir of water beneath its surface. Using data from the InSight lander and radar imaging, scientists have confirmed the existence of liquid water locked away in the Martian subsurface. This finding is monumental, as water is not just a crucial ingredient for life but also a key resource for future human exploration and colonization. The implications are both scientific and practical, offering a glimpse into Mars's past and its potential to support life today. Water has always been at the center of humanity's search for extraterrestrial life. On Earth, it is the foundation of all ecosystems, from the lush rainforests to the barren deserts. Similarly, the presence of water on Mars reshapes our understanding of the red planet's history. Billions of years ago, Mars was a very different place, with rivers, lakes, and possibly even oceans covering its surface. The discovery of underground water raises the question: could life, even in microbial form, still exist in these hidden reservoirs? The environment of these underground lakes is harsh by Earth's standards: cold, salty, and dark. Yet, life on Earth has shown us that it can thrive in the most extreme conditions. In the driest deserts, such as the Atacama Desert in Chile, microorganisms live deep within rocks, drawing moisture from the air. These environments, once thought inhospitable, now serve as analogs for conditions on Mars. If microbial life can survive in the Atacama, could it not also survive in the saline depths of Martian reservoirs? Salt plays a critical role in the story of Mars's underground water. At the low temperatures found beneath Mars's surface, pure water would freeze solid. However, the presence of salts, such as perchlorates, lowers the freezing point, keeping the water in a liquid state. This phenomenon has been observed in polar regions on Earth, where subglacial lakes remain liquid due to their high salinity. The same principle could be at work on Mars, providing a potential habitat for life in an otherwise frozen wasteland. The discovery of subsurface water also holds tremendous potential for future human exploration. Water is not only vital for drinking but can also be split into hydrogen and oxygen to produce rocket fuel and breathable air. An underground reservoir could become a life-sustaining resource for astronauts on Mars, reducing the need to transport water from Earth, a costly and logistically complex task. This finding also reshapes how we view Mars's climate history. The presence of liquid water today suggests that subsurface conditions may have remained relatively stable for billions of years, preserving a snapshot of the planet's ancient environment. These hidden lakes could act as time capsules, containing clues about Mars's transition from a warm, wet planet to the arid, dusty world we see now. But with such promise comes challenges. Accessing these reservoirs is no small feat. Advanced drilling technology will be required to penetrate the surface and reach the water without contamination. Scientists must also determine whether these waters are isolated pockets or part of a larger subsurface network, which could significantly affect Mars's capacity to sustain life. As we learn more about these underground oceans, parallels with Earth become even more striking. Subglacial lakes in Antarctica, such as Lake Vostok, have been sealed off for millions of years, yet harbor microbial life. Studying these extreme environments on Earth helps prepare us for the challenges of exploring similar habitats on Mars. This discovery is a reminder that life often finds a way, even in the most unlikely places. If Mars's underground lakes do contain life, it would revolutionize our understanding of biology, evolution, and the conditions necessary for life to thrive. Whether natural or alien in origin, Mars's subsurface reservoirs challenge us to expand our horizons and redefine our understanding of habitability. Each drop of water on the red planet tells a story, one that could ultimately answer humanity's most profound question: are we alone in the universe? Part 3. Was Mars once a paradise? Mars, The cold, arid planet we know today was not always this way. Billions of years ago, it was a vastly different world, one that might have resembled early Earth, with a thick atmosphere, a protective magnetic field, and flowing rivers, lakes, and potentially oceans. Mars may have once been a haven for life. But how did it transform into the desolate red planet? And is there any hope it could one day revert to its once habitable state? In its distant past, Mars boasted a thick atmosphere rich in carbon dioxide, creating a greenhouse effect that trapped heat and allowed liquid water to flow freely. Geological evidence from river valleys, deltas, and sedimentary layers captured by rovers like Perseverance and Curiosity tells the story of a dynamic, wet planet. The ancient Martian climate was warm enough to sustain liquid water on the surface. And with water comes the tantalizing possibility of life. The planet's magnetic field played a critical role in maintaining this climate. Similar to Earth's magnetic field, it protected Mars's atmosphere from being stripped away by solar winds. However, around 4 billion years ago, Mars's core began to cool, causing its magnetic field to weaken and eventually disappear. Without this shield, solar radiation bombarded the atmosphere, stripping it away over millions of years. As the atmosphere thinned, the surface lost its ability to retain heat, and water evaporated or froze, leaving behind the barren landscapes we see today. This transformation, while devastating for potential surface life, may not have been the end of Mars's story. Some scientists propose that the planet's climate may have undergone cyclical changes, with periods of warming interspersed with long ice ages. These cycles could have been driven by variations in Mars's axial tilt, orbital patterns, or volcanic activity, temporarily creating conditions favorable for liquid water. Could Mars have supported a thriving ecosystem during one of these warm periods? The discovery of minerals like clay and sulfate, which form in the presence of water, hints that the planet may have experienced prolonged intervals of habitability. Even more compelling is the evidence of organic molecules found in ancient sediments, building blocks of life that might have persisted in these temporary oases. This leads to an even bigger question: can Mars be revived? The idea of terraforming Mars, or altering its environment to make it habitable for humans, has long been a staple of science fiction. While the challenges are immense, the concept isn't entirely far-fetched. If the planet once had a warm, wet climate, could we artificially recreate those conditions? One proposed method involves releasing greenhouse gases like carbon dioxide stored in Martian ice caps to thicken the atmosphere and warm the surface. Another theory suggests deploying orbital mirrors to reflect sunlight and raise surface temperatures. However, these ideas face significant obstacles. Without a magnetic field, any atmosphere we create would still be vulnerable to solar winds, making long-term stability a major challenge. Despite these hurdles, the possibility of restoring Mars to a more Earth-like state continues to capture imaginations. Even small-scale efforts to warm specific regions could open up new opportunities for exploration and potentially create habitats for microbial life. These experiments might not only transform Mars but also yield insights into managing Earth's climate and mitigating the effects of global warming. Mars's past also serves as a stark reminder of the fragility of planetary environments. The planet's descent from a potentially thriving world to a cold, inhospitable desert highlights the consequences of atmospheric loss and climate change. Understanding what happened to Mars could help us better protect our own planet from similar fates. As we uncover more about Mars's history, we are left with a profound sense of wonder. What would the red planet have looked like during its prime, its skies cloudy with water vapor, rivers carving through canyons, and lakes teeming with microbial life? And more importantly, is that Mars truly gone? Or could it one day return? The answers lie buried in the planet's ancient rocks and frozen landscapes, waiting for humanity to uncover them. Whether Mars can ever be revived remains uncertain, but its history offers hope and caution in equal measure. If Mars was once a paradise, then it is a testament to the resilience and vulnerability of planetary ecosystems. Part 4. Traces of microbial life on Mars. Mars continues to surprise us with evidence hinting at the possibility of life, past or present. One of the most fascinating discoveries comes from the Jezero crater, a location that once housed a river delta. Here, NASA's Perseverance rover identified intriguing, leopard spots, patches rich in iron and phosphate. These elements are crucial for life as we know it, playing a fundamental role in biological processes such as cellular energy transfer and DNA formation. Their presence raises compelling questions. Could microbial life have once thrived in this environment? And if so, how might it differ from life on Earth? The significance of these leopard spots extends beyond their chemical composition. Their distribution suggests they were formed in the presence of liquid water, possibly billions of years ago when Mars was a wetter and warmer planet. On Earth, similar patterns are often associated with microbial activity in aquatic environments. For instance, iron and phosphate deposits are commonly found in areas where microorganisms metabolize minerals in water. This parallel leads scientists to speculate that ancient Martian microbes may have left their mark in Jezero's sedimentary layers. Adding to the intrigue, Perseverance has also detected organic molecules in the same region. These carbon-based compounds are the building blocks of life, though their presence alone does not confirm biological activity. On Earth, organic molecules can arise from both biological and non-biological processes, such as volcanic activity. However, their coexistence with water-formed minerals like sulfates and carbonates strengthens the argument that Mars once had conditions favorable for life. To understand how life might have existed on Mars, it's helpful to look at extreme environments on Earth, particularly hydrothermal vents on the ocean floor. These vents, often found near volcanic activity, spew mineral-rich water heated by the Earth's mantle. Despite the harsh conditions, complete darkness, high pressure, and toxic chemicals, these vents teem with life, including microorganisms that use chemical energy rather than sunlight to survive. Mars's Jezero crater could have hosted a similar environment. If volcanic activity beneath the surface heated groundwater, it might have created pockets of habitable conditions, even as the planet's surface grew colder and drier. This raises the tantalizing possibility that Martian microbes adapted to their harsh environment, evolving in ways that differ radically from earthly life. For example, Martian microorganisms might have developed unique metabolic processes to harness energy from minerals like iron or phosphate. On Earth, some microbes, known as chemolithotrophs, can survive by eating inorganic compounds such as iron sulfides. If similar life forms existed on Mars, their biological signatures could still be preserved in Jezero's rocks. But how do we confirm these hypotheses? Advanced tools like Perseverance's SHERLOC instrument, which can analyze the molecular composition of rocks, offer a promising start. By identifying specific patterns or isotopes associated with biological activity, scientists can distinguish between organic molecules of biological and non-biological origin. The implications of finding evidence for past microbial life on Mars are profound. It would demonstrate that life is not unique to Earth and could emerge independently under the right conditions. This discovery would also reshape our understanding of evolution, showing how life adapts to radically different environments. However, the absence of direct evidence for current life on Mars does not rule out its existence. Subsurface reservoirs, shielded from radiation and temperature extremes, remain promising candidates for hosting microbial life today. If microbes have survived in these hidden habitats, they could offer insights into how life endures in hostile conditions, not just on Mars but on icy moons like Europa and Enceladus. The possibility of Martian life also raises ethical and practical considerations. If life exists, how do we study it without contaminating its ecosystem? And if no life remains, could we introduce Earth-based organisms to kickstart a new biosphere? These questions add layers of complexity to the already challenging task of exploring Mars. As we continue to analyze Jezero's leopard spots and other intriguing discoveries, we are reminded of how much we still don't know about Mars. The red planet's potential to harbor life, past or present, remains one of the greatest mysteries in science. Each new finding brings us closer to answering the age-old question: are we alone in the universe? Part 5. Seismic activity and mysterious subsurface structures on Mars. Mars's quiet exterior hides a dynamic interior. Thanks to NASA's InSight lander, scientists have uncovered seismic activity on the red planet that suggests the existence of mysterious subsurface structures. These Marsquakes, as they are called, reveal that the planet is not as geologically dormant as once thought. The vibrations detected by InSight's seismometer hint at a complex underground network, possibly shaped by volcanic activity, tectonic shifts, or even flowing water. The data collected has revealed two key anomalies. First, there are signs of significant seismic activity in regions like Cerberus Fossae, an area known for its fissures and evidence of recent volcanic flows. These Marsquakes suggest that Mars's interior remains active, with heat and energy potentially capable of sustaining pockets of liquid water beneath the surface. Second, some seismic patterns are so unusual that they defy simple geological explanations, leading to speculation about the presence of vast underground caverns or networks. To better understand what these structures might look like, we can draw parallels to Earth's Mammoth Cave system, the longest known cave network in the world. Mammoth Cave is not just a geological wonder, it's a thriving ecosystem. Despite the complete absence of sunlight, unique microbial and fungal life forms have evolved to survive in its dark, mineral-rich environment. If Mars's subsurface structures resemble such caves, they could provide a similar refuge for microbial life, shielded from the harsh surface conditions. Mars's subsurface environment offers key advantages for potential life, while the planet's surface is bombarded by deadly radiation and subject to extreme temperature swings. The underground layers provide natural insulation and protection. Furthermore, if water exists in liquid form beneath the surface, kept from freezing by geothermal heat or the presence of salts, it could sustain life in ways similar to Earth's subterranean biospheres. The possibility of subsurface life on Mars is more than theoretical. On Earth, extremophiles, organisms that thrive in extreme conditions, have been found in environments previously thought uninhabitable. Deep within Earth's crust, microorganisms subsist on chemical energy derived from rocks, independent of sunlight. These findings expand the definition of habitability and make the idea of life beneath Mars's surface all the more plausible. But could these underground structures be something more than just habitats for microbial life? Some scientists have speculated that seismic data might indicate the remnants of ancient lava tubes or water-carved tunnels. Lava tubes, formed during volcanic activity, are known to exist on Mars and are larger than those on Earth due to the planet's lower gravity. These hollow spaces could be vast, stable, and capable of sheltering both life and future human explorers. The implications extend beyond the search for life. Subsurface structures could hold vital clues about Mars's geological and climatic history. By studying these formations, scientists can uncover the processes that shape the planet and possibly determine how it transitioned from a warm, wet world to the cold desert it is today. Furthermore, these structures may contain reservoirs of water or frozen carbon dioxide, critical resources for future missions. Exploring these hidden structures poses significant challenges. Advanced drilling and seismic imaging technologies will be required to map and access the Martian subsurface without causing contamination. Robotic probes equipped with spectrometers and cameras could venture into lava tubes or boreholes, providing real-time data about these mysterious environments. Beyond scientific curiosity, the idea of underground life on Mars sparks profound philosophical and imaginative questions. If life exists in these hidden realms, what would it look like? Would it mirror the extremophiles of Earth, or would it represent a completely unique biological framework? Moreover, what does the possibility of such life mean for humanity's place in the cosmos? The discoveries made by InSight have already expanded our understanding of Mars. But they are only the beginning. The seismic signals it has detected are like whispers from the planet's depths, hinting at secrets that could rewrite our understanding of habitability. Whether these signals lead to evidence of life, reservoirs of water, or clues about Mars's past, they represent an invitation to explore further. Mars's underground structures challenge us to think beyond the visible and venture into the unknown. They remind us that the red planet's greatest mysteries may lie beneath its surface, waiting to be uncovered, whether through robotic explorers or human ingenuity. The quest to decode these signals promises to bring us closer to answering the ultimate question: is Mars a dead world? Or does life still linger in its hidden depths? Part 6. the future of Mars, exploration and colonization. The quest to uncover Mars's mysteries is not just about understanding the past, it's about shaping humanity's future. Upcoming missions, such as NASA's Mars Sample Return, aim to bring Martian rocks and soil back to Earth for detailed analysis. These samples could provide critical insights into Mars's geology, climate history, and even potential signs of ancient life. Meanwhile, cutting-edge technologies like MOXIE, Mars Oxygen in Situ Resource Utilization Experiment, are paving the way for sustainable human presence by converting the Martian atmosphere into breathable oxygen. Colonizing Mars has long been a dream of visionaries, and recent advancements bring that dream closer to reality. A permanent human settlement on Mars would require overcoming extreme challenges, including the planet's thin atmosphere, harsh radiation, and freezing temperatures. Yet, innovative solutions are emerging. The concept of using genetically engineered microorganisms to produce oxygen and grow food is one such approach. These microbes could thrive in controlled environments, transforming raw Martian materials into vital resources. This bioengineering approach has already seen success in Earth-based experiments. For example, researchers have modified algae to produce oxygen more efficiently, and similar methods could be adapted for Martian conditions. These advancements suggest that we could one day create self-sustaining biospheres on Mars, reducing our reliance on resupply missions from Earth. Another promising avenue is the development of technologies inspired by extreme environments on Earth. In Antarctica, scientists have tested autonomous habitats capable of withstanding the continent's brutal climate. These stations, equipped with renewable energy systems and life support technologies, serve as prototypes for Martian habitats. By building on these successes, future Martian outposts could provide safe havens for astronauts, complete with radiation shielding, water recycling systems, and food production facilities. The potential benefits of Mars colonization extend beyond survival. Establishing a presence on Mars could accelerate advancements in robotics, energy, and material science, many of which would have applications on Earth. For example, innovations in energy storage and waste management developed for Mars could help address sustainability challenges here at home. Additionally, the experience gained from living on Mars could serve as a stepping stone for exploring even more distant worlds, such as the icy moons of Jupiter and Saturn. However, the path to colonization is fraught with obstacles. Building and maintaining a human settlement on Mars would require enormous financial investment, international collaboration, and decades of research and testing. Furthermore, ethical questions arise about the potential impact of human activity on Mars's environment. If microbial life exists there, how do we ensure that we do not contaminate or harm its ecosystem? Despite these challenges, the vision of a human future on Mars is compelling. It represents the next great leap in exploration and offers humanity a chance to become a multi-planetary species. As we stand on the brink of this new frontier, each mission and discovery brings us closer to realizing that vision. Mars is not just a destination, it's an opportunity to redefine what's possible. From returning samples to creating oxygen on site, every step forward unlocks new possibilities for exploration and survival. The Red Planet, once seen as a barren wasteland, is now viewed as a potential second home for humanity, a place where science, ingenuity, and determination could turn the impossible into reality. Mars continues to astonish us with its unresolved mysteries. From the clearest image of a strange structure to discoveries of water, microbial life, and the potential for colonization, each revelation brings humanity closer to unlocking the secrets of the Red Planet, and perhaps our own future. Could the answer to life beyond Earth lie beneath Mars's red dust? The truth may be closer than we think. If you love content about space exploration and mysteries, don't forget to like, share, and subscribe to our YouTube channel. Thank you for watching.